Now, it's important to realize that the answer is not simply going to be where the object ended minus where the object started, because if I travel a mile to the store and a mile back, I have traveled 2 miles, even though I started and ended in the same place. So we will have to account for turning around and count every distance traveled as positive. So we start by computing the velocity, which is the derivative of position. And here we get 6t squared minus 6t. The next thing is to find the t-values where the velocity is 0. And that happens when 6t squared minus 6t, which is 6t times t minus 1 equals 0. And we can see that happens when t equals 0 or when t equals 1. Now we want to determine where s of t is increasing and where s of t is decreasing. We'll need this so that we count both pieces of the path as positive distance. So what we do is we draw a sign chart for s prime of t, the velocity. We note that it's 6t times t minus 1. So when t is bigger than 1, both of these terms are positive, and we get positive for s prime of t. Between 0 and 1, 6t is positive, but t minus 1 is negative, so that product is negative. And then over here, between 0 and minus 2, both of these terms are negative, so the product is positive. And we conclude here, positive means going forward, negative means going backwards. So we can see that s of t increases between minus 2 and 0 and between 1 and 2. So the object's moving forward. And s of t decreases between t equals 0 and t equals 1. The object moves backward. So we take a look at our chart and we draw a path diagram. And what we'll need is the position of the particle at important points, and those are going to be the endpoints. And our 2 points, 0 and 1, which apparently from the picture are places where the path turns around. So we start by computing s of minus 2, which is minus 18. S of 0 is 10. S of 1 is 9. And s of 2 is 14. Now we start at the beginning of the time interval, t equals 2, and we're at position minus 18. We move right to where we are at t equals 0, which is s equals 10. Now we're going to move left to t equals 1, which is s equals 9, and then we're going to move right again to t equals 2, where s equals 14. And that's a complete description of the path. Now what we're going to do is measure the length of the 3 parts of the path. First, from minus 18 to 10 is 28 units. Next, from 10 to 9 is 1 unit, and then from 9 to 14 is 5 units. When you add those up, you get 28 plus 1 plus 5, which is 34 units, which is the total distance that the particle traveled.